I'm Bob Bolton from the University of Alaska Fairbanks, and this is Alaska Voices, a place for communities to connect through conversation in order to build a better tomorrow for Alaskans and the world.
Originally, I grew up in Gakona, Alaska,
Tyonek,
Egypt,
Idaho,
Rampart,
St. Lawrence Island,
St. Paul.
and I'm here with my student,
my science buddy,
my teacher,
my homie.
I'm his daughter.
Okay, I'm Cathy Wilson. I'm 62 years old. I'm with my friend, Matt Hevner.
And I'm Matt Hevner. I'm 46 years old. And we're friends and colleagues and co-workers, co-conspirators.
One of the things that I've really loved about working at Los Alamos National Lab, I'm sure this is the same at many of the national labs, is the opportunity to, and the kind of the need to be flexible in terms of how you apply your science and what kind of big national questions or issues come up. We had the big Cerro Grande fire. Were you in Los Alamos when that happened?
Well, when the Cerro Grande fire happened was 2001.
That's right.
And we were up here in Fairbanks for our graduation.
Oh,
So we lived, and we had some dog sitters who had to evacuate our dogs several times during the fire. And we were up here trying to find out what was going on. But you were down there for the...
Yeah, so we had just moved from Australia. You know, we were trying to figure out where we wanted to live, and we were renting a house, and the fire hit, and everybody evacuated, and we were like, oh my gosh, I hope our new place of employment doesn't burn down. But on the one hand, it was a tragedy for many of the families who lost their homes. Thank goodness nobody lost their lives in that fire. We were asked to figure out, how these legacy contaminants, still low level, that were in these, spectacular canyon streams, how would they be transported by the massive post-fire floods that would occur? This was a big opportunity to play a role in bringing math together with the natural sciences to develop an understanding and help make decisions about how do we control the way material is going to be moved off of these hill slopes, where will it go in the Rio Grande River system, how will it impact surrounding areas, especially things like the local native Pueblo lands and things like that. And was my first real awareness of the super strong connection between science and decision making. But you had been there when there were still forests on the
we moved
mountain front.
Yeah, and we actually lived up in the Jemez Mountains. We moved there in January 2000, I guess, is when we got there. So we saw the forest and then saw all the change. Still too much fuel up there, even now.
So how did you get into what you do now? You came to the lab, you got involved in some of the national security work.
Yep. I'll back up a tiny bit. So my graduate work here at UAF was on middle atmospheric lightning. Was the potential for the energy to be a catalyst for ozone chemistry or, excited state chemistry. So very nerdy, very geeky, very very detailed, and I could latch it on to the, climate impacts or anything, but that wasn't really where my focus was. It got some attention at AGU, the American Geophysical Union meeting. I started meeting some folks from LANL there, and they were really interested in this. Looking back in hindsight now, I can understand even more so why the lab was so interested. But the lab's legacy in nuclear test detection and support to the U.S. government for test ban treaty verification. And if somebody violates that and does test, the forensics and understanding all the nuclear weapons outputs that we could measure has been a huge legacy of the lab. And so there's a satellite-based component to that where they're looking for bright flashes of light. And if there's this previously unknown flash of light in the atmosphere, is there the potential for that to be a background false trigger? Depending on what it looked like, it could potentially, go straight to DOD and say somebody's setting off nukes, or it could just be, hey, this was a weird thing, we need to dig in and understand it. Or if we understand the background, hey, we got that one, we know what that is. So the lab recruited me pretty heavily because I had this fresh PhD on this unknown flash of light in the atmosphere that they were really interested in understanding. So I got to the lab, and I started out just doing basic pure science of looking at the radio outputs. That's when I started to learn, how the lab does bring basic science to really address national security needs. The more time I spent at the lab and looked at the kind of questions we deal with, I really understood how you need basic, good scientific understanding and then look at the geopolitical context and what's going on.
One of the great things about being at the National Lab was that you really do have to work on big problems of national interest. And the first problems that I worked on after, the Cerro Grande fire happened and we had to respond to that were related to the impacts of climate change on water for energy. And the fact that for a number of years I was working on problems for Department of Energy, trying to understand how climate change, long-term climate change, coupled with extreme events like droughts, how would that affect the availability of water in the Colorado River Basin, let's say, for electric power generation and the application of electric power generation in doing things like oil shale development or oil development. I was given an opportunity to lead a project that enabled me to pull together all of the Arctic climate science at Los Alamos, and that included pulling in the work that is done in terms of sea ice, ocean, land ice shelves, ice sheets. But one piece that was missing at at Los Alamos that we didn't do that much at that time was permafrost. So we had some folks who were working on Martian planetary science, and we asked them if they could tailor their models from the Martian landscape to Earth permafrost landscapes. From there, we developed some early calculations of impacts of climate change on permafrost, called up Larry Hinsman, who was then director of the International Arctic Research Center at University of Alaska, and said, hey Larry, we're really interested in the work you guys are doing. Can we form some partnerships and see if we can build a new program in this area with Department of Energy? And that's how I became an Arctic climate scientist, which is what I am now, and which is probably the most fun thing I've done in my whole career.
I'm curious, what makes it fun?
Getting back to that early thing we were talking about of how do you use mathematics and computation to describe a system that's changing extremely rapidly, has big impacts, not just locally, but globally, being able to get out in the field in the spectacular wilderness through different seasons from, the spring when it's snow-covered with really phenomenal colleagues and friends from University of Alaska, and collect the data and integrate it into these models. It's a once-in-a-lifetime kind of experience.
Yep.
Alaska Voices builds bridges by creating a space where community members, friends, policymakers, and scientists can share stories and place-based knowledge. This project was developed in partnership with StoryCorps and was funded by the Alaska Climate Adaptation Science Center. Additional funding was provided by the University of Alaska Fairbanks Chancellor through a generous gift from the Bentley Family Trust. Alaska Voices would not be possible without the help and efforts of an amazing group of people. Our producer and audio engineer is Kelsey Skomberg of Mossy Stone Media. Our podcast and outreach specialist is Michael Deleu, and our website designer is Carolyn Rosner. If you are interested in more conversations or information, please visit our website at alaskavoices.org.